Hey students, Mr. Halpern here. We're going to talk about cycloalkanes and aromatic compounds. So, you'll notice a couple of things that are common between cycloalkanes and aromatic compounds. But you're also going to notice a couple of things that are pretty similar to those and alkanes that we've been talking about, and alkenes and alkynes. All of these things that we've talked about, alkanes, kenes, kynes, cycloalkanes, which we'll talk about in a second, and aromatics as well, all of these have carbon and hydrogens, right, as a base. So that's just something good to know. So let's talk about cycloalkanes, right? Alkane is in there, so we're definitely talking about carbons and hydrogens. And this is considered a saturated hydrocarbon. Much like our alkanes that we have from when we first learned alkanes, we learned that they have hydrogens around all of their carbons, as many as they can have. But the difference is that cycloalkanes are made up of carbon atoms joined in rings. All right, so joined in rings. So if you notice, for example, below, I have cyclohexane. All right, cyclohexane has a ring of 6 carbons, and there's no sort of end and beginning. There's just a ring of them. Each carbon has 2 hydrogens. So if you look there, there's no ending, and so if you remember, on each end of an alkane, each end has 1 extra hydrogen than the other ones in the middle, and so that's why we have the CnH2n plus 2 for alkanes. Cycloalkanes, when you join an alkane together by its ends to make a ring, 2 of the hydrogens have to come off, and so they in fact have a CnH2n formula. All right, so it's good to remember that yes, cycloalkanes are single bonded with their carbons, but they've lost 2 hydrogens in making that ring. So some names of some common cycloalkanes. The first one we have is 3 carbons in its structure, and it's called cyclopropane. This is how we name it, cyclopropane. It's propane, but it's cyclo, it's a ring. Okay, molecular formula would be, can you guess before I show you? Well, propane has 3 carbons, and cycloalkanes have a CnH2n formula, so it would be C3H6. All right, the next one has 4 carbons. This would be cyclobutane, and it has 4 carbons, so C4H8. The next one has 5 carbons. This is cyclopentane, good, and its molecular formula would be C5H10. As you see there, there's a ring of 5. All right, and finally cyclohexane for 6 and C6H12. Okay, sometimes we simplify the structural drawings of these to make just the geometric shapes. As you can see in the cyclohexane there, you have a hexagon as a shape there for cyclohexane. All right, for cyclopentane, we just draw a triangle, or butane, we just draw a square. Okay, so that's a simplified drawing of them. All right, now these are considered building compounds, meaning we can build off of these. Just as we talked about with alkanes, alkenes, and alkynes. You can build off of them. Aromatics are similar to cycloalkanes, except for one important difference. Aromatics are unsaturated hydrocarbons. And they are made up of carbon atoms joined in rings, just like the cyclohexanes and the cycloalkanes. Right. They have a formula here, and it's C sub N H, and then it's sub N as well. All right, so however many carbons you have equal number of hydrogen. So the reason why you have that is because it's unsaturated. And if you look at the example that we have right here, you'll see that benzene, and I'll move this down, benzene has a structure that has double bonds on every other carbon. So it has a total of 3 double bonds. But those double bonds can actually rotate around and flip to the next carbon. And when you think of double bonds, remember covalent bonds are just sharing of electrons. And so when we're talking about flipping double bonds, as I just said, you're just moving electrons around. So electrons are actually moving around this ring of carbons. Right? Extra electrons are moving around this ring of carbons. And so we can often see this being drawn as a hexagon, right? In the case of benzene, hexagon, with a circle in the middle to represent the movement of electrons around the middle of the benzene ring. Okay? Now benzene, you don't have to memorize all of these different examples, or actually any of these different examples that I have on the right, but it's good to note that benzene, again, is a builder molecule. We can take this structure of benzene and add other benzenes, right, to make naphthalene or anthracene, or you can also add hydroxide groups, OH, to make a phenyl, or CH3 to make toluene, and all of these are great for many different reasons. These are called aromatics because lots of them have aromas. The smell of aromatic compounds kind of gave it its name, or their name. Okay? So know the basic molecular formulas of each kind, and know the basic examples, benzene and cyclohexane, and how to draw them. Okay? All right. See ya.